Can I taste your juice?
Hey folks, PBusardo. The reviews are definitely backing up. They are definitely, without a doubt, backing up. A bunch of stuff came in. I do want to take a look at the Inikin T20S because I want to do videos on starter kits as well as advanced devices. And you know, the number of views that I get on a device like this won't be the same number of views that I get on a device like the maybe the MX or the SX Mini MX class, right? This new guy here. But I still think it very, very important to look at starter kits for those folks who want to transition into vaping, into tobacco harm reduction. And although those videos may not be very interesting for some of you folks who are watching right now, I would certainly hope that you would send smokers to watch a video like that, right? So the T20S came in, this new starter kit from Joytech, the Exceed. This one came in. Finally, the Siren 2 retail editions came in, or final market edition. This is going to be the 24 millimeter. Yeah, 24 millimeter. This is going to be the 22 millimeter right here. So a lot of stuff coming in. I'm getting backed up. I'm doing these as fast as I can, especially with all the travel and things that I have going on. So just stay tuned, folks. We'll get to them. But today we are going back. We're going back to Evolv. I had the opportunity to travel out to the Evolv facility again, and the first time I was there, and as a matter of fact, there's going to be probably a link right up there right now, and also a link in the description of this video, the first time that I was able to visit Evolv, which was in the June 2014 time frame, okay? So a lot of things have changed. They are in a completely different facility, completely different building. They have a lot more capacity right now. So we're going to see the factory. We are going to see boards being made. We are going to see the steps of those boards being made, kind of from the start to the very, very finish, the testing and evaluation that goes on. We're going to see it all in this video. They really did allow me to shoot everything. But we're also going to have a very, very interesting conversation with Brandon and John, the co-owners of Evolv. And I'm not sure if this is going to be, it's definitely going to be a two-part video, maybe even a three-part video, because, you know, a lot of people, they'll edit down interviews to the most exciting stuff. I think it's interesting. I think it's all interesting because we talk about FDA and regulation and PMTA and just like pretty much a lot of stuff. And I thought it interesting to bring that all to you. You don't want to watch a fast forward past stuff, but I think it more interesting to have it all inclusive and to have everything that we talked about in this video, okay? So that is what we are going to do in this video right here, and we are going to kick it off with the interview, and then we'll work into the other factory. So let's kick it off. Evolv 2017 now, 3 years later, with Brandon and John, the co-owners of Evolv. So here we are again at Evolv. How many years was it when I was here the last time? It was three. It was about 3 years ago. And I am sitting with Brandon and with John. You may know Brandon because Brandon's been over the house. We've interviewed Brandon. You may have seen him at shows. John, you may not have seen. You may know me
from the last time.
But and that's why I wanted to do this. I wanted you to both introduce yourselves again, and because unless you saw the last video, maybe you don't know who these two are. So let's start off with Brandon. Who are you, and what is your...
Brandon Ward. I'm co-owner of Evolv.
Okay.
Started Evolv back in... Really, the idea of Evolv started back in 2009.
Okay.
I was a 2-pack-a-day smoker. Got an e-cigarette in, I guess it was the end of 2008, beginning of 2009, and started fiddling with different things, modding different things. Mm-hmm. Could not, you know, am not an engineer. Could not get what I wanted. So I went looking, and I found John. And John wouldn't talk to me, and wouldn't talk to me, and wouldn't talk to me. And I finally showed up, and I got him to talk to me, and all of the ideas I had that were so grand, he had such better ideas. So we ended up, you know, that's how Evolv got started, and that's where I came from.
Very cool.
I was a very heavy smoker, and
yeah.
I had tried a bunch of crap to quit, and I couldn't do it, and it just kept getting better. What he had proposed, I think we tried it within
I had to talk him into wattage control. That was our major.
That was our major. He's like, why are you guys trying to control this with voltage? I'm like, because that's what we do. And he's like, well, that's...
Yeah, but the 6 cartridges that you had me test, you're like, oh, you got to do this one here. Okay, that's 6.5 watts. Got to do this one here. That's still 6.5 watts. Got to do this one here. So eventually, it's like, well, you're just setting watts in a roundabout way back in the day. And yeah, I was doing robot parts and power supplies and things like that. And when you're dealing with that, you deal with a lot of Yahoo inventors who have long on ideas and short on knowing how to do anything, and even shorter on dollars. So you blow a lot of them off, but.
So is that why you were blowing him off at the start?
Yeah, pretty much. Because, you get 10 of those a day where it's like, I need you to work on my perpetual motion machine. If the power converters were 4% more efficient, it would be over 100% efficient. And you're like, yeah. But the difference between 98 and 102, that's bigger than you understand. So, no, you get a lot of Yahoos, and you have to send a lot of Yahoos.
So against meeting with me.
Well,
so against it. Emails, call. I would keep calling. I'd call every day.
Well, I don't know if you've ever dealt with Brandon, maybe if you're on the sales side too. The other thing with Brandon is he leaves messages like, this is Brandon, call me back.
no explanation.
Or you'll be like, or even worse, you'll be like, this is Brandon, I got something really exciting for you.
I got those.
Yeah. I'd call you back if you would tell me what the exciting thing is, but you're sort of teasing it. So
what finally got you to work with Brandon?
Well, he wouldn't go away, and
it's tenacious.
Well, that was part of it. It was 2009, so that was in the depths of the crash, so we were slower than usual. So it was like, well, whatever, I'll talk to some of these yahoos. And then he came in, and there was enough interesting stuff going on. It was an interesting enough problem space, so we just started sort of chewing on it. But a lot of it is Brandon's a good salesperson. He's tenacious, and but the other thing was, Brandon wasn't even the first e-cigarette people to talk to me.
Interesting. Okay.
Because we were doing like Swatch 3s. We had some off the shelf DC to DC converters people were using to mod e-cigarettes, and this is back in like 08, 09. The 5th or 6th time you hear, oh, it's like a flashlight. It's not a flashlight, but it's like a flashlight. You start saying, okay, well, maybe I should dig into this a little bit and see what's going on, because people keep asking about this sort of thing. So eventually I dug into it enough to know more or less what they were talking about, and that's when Brandon showed up again. So, eventually that worked out okay, and it was really just the whole, hey, you guys should be controlling on watts, and I've been making DC-DC converters and things for quite a while, so I knew we could do that.
I can remember when he said yes. I was coaching.
Said yes. like he said.
I was coaching. No, said yes to coming on to Evolv, because my original thought was pay John to do it, and then we started bouncing numbers around, and I'm like, oh my god.
Yeah, this is the other thing with inventors is they never understand how much these things cost.
Right. And I was coaching one of my kids' teams, and I had my headset on, and I'm trying to coach, and I'm walking back and forth, pacing back and forth across the field, talking to John, trying to convince him that he needed to come in as co-owner.
And fund it, by the way.
Yeah, fund a lot of it. And he finally said yes. He was like, okay, all right. I'll do this.
So you are.
And it was only because it was interesting to him. That was the only reason.
He comes that kind of guy, right?
Yeah.
Well, I had plenty of stuff to do with robots. I mean, if I'd been working on robots instead of e-cigarettes for the past 5 or 6 years, I mean, I might not be in this fancy building, but I'd be in a fancier one than we were in last time.
So you are the co-owner of Evolv, right? So you guys are the only owners of the company. Now, you said something interesting before, and wasn't that the promise of wattage at one time? When you said you connected this cartomizer and it was 6 watts, and then you connected this cartomizer and it was 6 watts. And so back with my early days of wattage, back when resistances were not where they are today, I could use the same wattage and get the same experience. That's definitely not where we are today.
Well, but think about what the consumables were then. It was all cartomizers that were built exactly the same, except this one had a little bit different wire. That one had a little bit different wire. They were all the same thing. Whereas right now, if you say, well, I've got 8 tanks, some of them, those are horizontal coils, some are vertical coils, some are multiple coils, some are, heavy high thermal mass, some are low thermal mass. So the space has gotten wider. So the number of things that you have to control is bigger. So the device efficiencies from watts to, vapor output has changed, things like that. So no, it was a smaller number of things that we're having to control because it was just cartomizers.
Just cartomizers.
Yeah, it really was. Yeah. And the little atomizers like the HH.
The little drippers.
Sure.
Right. So
Watts was the right way to.
Watts is thermodynamically correct. We could do it in BTUs if we wanted a different number.
So let me ask you this: you said wattage is thermodynamically correct. It's the correct number to use.
Mm-hmm.
Okay. So I got used to volts.
Yeah.
And then I had to get used to watts.
Yeah.
And of course I deal with amps and I deal
Sure.
with resistance, right? And then all of a sudden Yeehigh throws me a curve with joules.
Sure.
Okay. What do you think about the measurement in joules? Because when I look at that device and I do temperature control,
Yeah.
to me it's a 1-to-1 correlation of wattage.
It is because that was really them trying to a watt is a joule per second. So they just dropped the per seconds and called watts joules because they wanted to get around a patent that we had, I think.
That's kind of what I thought.
That's the reality of the situation.
Okay.
But no, that's sort of like saying, oh, no, I'm not going 100 miles an hour, officer, I'm going 170 kilometers an hour. Sure, you're not wrong, but it doesn't change the speed you were going. Your power output is in watts, period, hard stop, your power output is in power. Mm-hmm. Whether you want to have that in watts, or you want to have that in BTUs, or you want to have that in, joules per second, which is 1-to-1 watts.
Okay. John said that it was a tragically boring backdrop.
It is a tragically
boring
background.
Of all of the options we have,
You're out of the frame now. You gotta
I figured.
Well, you know what I'm gonna do? Maybe I can edit an Evolv logo in there.
Oh, there you go.
I can just go to the final plotter and make an Evolv logo.
No, I think it would look funnier if there was an edited in Evolv logo.
Right.
So I might just have to do that. So the last time I was here, it was the DNA 40.
Yep.
Since then, it has been the 60, the 75, the 75C, the 200, the 250. So you guys have been pretty busy.
Mm-hmm.
And now we have the new building. So.
Oh, we've had this since 16.
Okay.
January of 16.
So when I was there, you had the second line, but it wasn't fully operational yet, if I remember correctly.
We had some parts of the second line.
Right.
Up and running. Now we have 4.
Right. Was the purpose of moving here to increase your capacity?
Yeah. Increase capacity, increase space. We were in 8,000 square feet before. Now between the two places we have 44,000.
44,000. Wow.
Yeah, because when you were last here, I don't remember how many boards we were doing. Well, let me just run the numbers real fast. We had nameplate capacity of 30 plus. So we had nameplate capacity of 42,000 parts an hour. Now we have nameplate capacity of 300,000 parts an hour.
Wow.
So, and that doesn't even count the prototype line. So, no, we're about 10 times faster than we were.
How has the scene changed for you? Obviously you're making more boards, right? Have you seen a plateau yet, or is it just continuing to grow and grow and grow?
We were pretty much up until 17. 17 has been kind of flat, but I'm not sure how much of that is the scene has changed and how much of that is we spent most of 17 so far working on our PMTA stuff. So we launched, like you said, we had this board and that 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 board.
Right.
And we've got probably that many again in our August 8th pipeline that we've sold and prototyped and whatever. But we've of that put into wide release 1, which is the 75C. And the reason for that is largely because the PMTA stuff's a lot of work.
Right. It was all hands on deck for the last.
Right, and then all of a sudden they're like, do all these things as fast as humanly possible, pay experts, blah, blah, blah. And then they're like, by the way, years and years and years. So, I would anticipate more of our August 8th stuff will come out sooner just because really, under the old rules before a couple of months ago, 10 months from now, vaping industry is over unless you were done with PMTA.
Right.
Which is I was a little mad when they kicked it so far, just because we had spent so much time and effort and energy doing it, and money. Oh God, yes, money. But doing it really, really fast. If they'd said, "Hey, do this as a 6-year plan," we could have started it differently. So it's not so much even that I mind what the regs are, but pick them and stick to them rather than just sort of making stuff up on the fly would make our lives a whole lot easier.
And then changing them too, because like you said, you've dumped a lot of money into it, you've dumped a lot of time and energy into it, and you mentioned PMTA, so that's probably a path that we should go down. Obviously, Evolv, because you're talking PMTA, you're in it for the long haul.
Oh yeah.
Right? You don't plan on going away because of the regulations.
No.
We started work toward a PMTA back when the draft guidance leaked. That was, what, 3.5 years ago?
Yeah.
Yeah. I mean, we started work toward that. I mean, all of the things that you've seen since have been sort of layers on that, on that theme.
Right.
Because I guess the thing where I personally differ from a lot of people in the industry is when you really read through the PMTA guidance, there aren't any questions the FDA are asking within the framework that they have to work with from their mandate from Congress that I really wouldn't want answers to. So it's not that they're asking things that are just ridiculous beyond the pale. They're asking for a lot of work, but the fact that as an industry we haven't done the work isn't really on them. So I don't know that, the timeline might change. If you change the approvability category from appropriate for the protection of the public health to something else, then what questions they need to have answered might change, but that's not on the FDA, that's on Congress. I don't see, in the short to medium term, I don't see, even if it goes to being somebody else, I don't see it being necessarily easier, just because, if you really drill down the PMTA guidance to its most basic essence, it's show us that these things are safe and then prove it. I would like to know that as a vapor. I'm actually still not a vapor, but if I were a vapor, I would like to know that. I don't think it's responsible for us to say, well, for the next 100 years, we're just not going to answer these questions. But somebody has to do the work to say, this is what a safe, approvable product looks like, and this is not what a safe and approvable product looks like, and then show us that you're in this category. The difficulty with PMTA, where everybody's getting the major frustrations, is with the PMTA structure as it is right now, it's, okay, companies go do both of those. So show us what you're doing, and then show us what you're doing is safe, and then show us how you have proved that. I guess safe isn't exactly the right word, because it's not safe and effective. It's appropriate for the protection of public health. But basically they're putting both sides on us because they don't know any better than we do. So if it changed such that, it went to product standards or something like that, where they wanted to take the half that says, here's the box we'd like them to fit in to be called safe, that would make it somewhat easier, but at the same time, that would be much more limiting. So if, the way they have it right now, they say, okay, come up with a safe product, or I keep saying safe, which is the word we want, but it's not the it's not the FDA word. But show us that these products are appropriate, and show us why, is a lot more freeing than if they said, okay, well, we're going to say that beyond 4 volts is unsafe because we tested some cigalikes back in 2011. That really ties your hands. So, like, for example, if they said, well, we tested some flavors of some juices and we've decided that the things that are non-appealing to children and are reasonably well studied and whatever are these 3 artificial tobacco flavors plus pure menthol, period, hard stop, show us that you fit in that box. I don't know that that is long-term better for us as an industry. Short-term, it makes it easy because then you don't have to spend a lot of time doing a lot of in vitro work where you're testing the toxicology of this berry flavor or this custard flavor or whatever you're doing. But it's not necessarily a more flexible framework, and it's not a framework that's more amenable to innovation. So I'm not sure that that would be long-term a win. The reason I'm not sure that would be long-term a win is because, obviously, if you look at the CDC numbers and some of the other things in the adoption rates, these products aren't good enough yet. If these products were good enough and we could show that and demonstrate that and shout that from the rooftops, it would still be 2014, 15, where we were, the news story said, hey, look, these things are helping people quit smoking. The smoking rates would be continuing down at a precipitous trajectory rather than notching back up or leveling off or just going back to the trends. So if product standards lock us where we are, I don't know that that's necessarily better than the sort of more flexible PMTA show us that this is appropriate and show us your work. Now, some of that I may feel that way because we've already spent a lot of time doing a lot of the things to do it that way, but I just can't imagine, unless Congress gets involved, any responsible regulatory body not wanting you to be able to show what your population exposures are, what your metals are, what how much of this, that, and the other thing you're getting, or if you're making a juice, show us that this is safe to breathe. I mean, the timeline was insane.
Yeah.
Everybody agrees with that, but the FDA agrees with that. The timeline was insane largely because the basic science isn't there, and I think the more the FDA poked into, okay, what's actually known, the more you're like, oh man, these guys are...
I don't think they realized how little science there was. I think they were expecting, well, just go pull from the well.
Right.
Of all this vast science that's been done. And there's, one of the things we did pre-PMTA was a literature search, where they went through all of the studies, took the studies and said, okay, these ones would pass FDA rigor.
And then what can you extrapolate from that to your products or to the category or whatever? And there's
not much.
Yeah, there's not a ton out there. Mm-hmm. So... but there really needs to be. If you gun to any of our heads, are these products appropriate to foist on the market? I think the best we could say is maybe. I don't know that anybody's done it to the point of having all your I's dotted and T's crossed and things tested in all the corner cases and whatever, like you'd have to do for a PMTA. I know I don't have all of that work done, or I would have already put my PMTAs in, and I don't think anybody's ahead of us, at least in the independent vapor space. Mm-hmm. One of the things we're doing with our PMTA that I don't know that anybody else is trying to do with the level of rigor is we're trying to demonstrate that for a certain set of hardware products, any approvable open system e-liquid will be safe in this product, which is...
If it's safe going into the...
Well, right. So that's the thing is, if the FDA says, well, great, we've given PMTA approval to these 400 e-liquids, any of those has to be, for any open system to be approvable, any of those ones on the market has to be, safe to use in an approvable open device, which isn't a problem that a closed system has, because you say, okay, well, we offer 4 flavors. Here's our test data for 4 flavors.
And it's testable end to end. It's
right. Which is a much harder bar, but I think we all know that if the market is only $5 1 milliliter Juul pods, it's going to be a much smaller market, and it's going to be a market that's much less appropriate for a lot of users. So we feel like just because of the cost differential will push a lot of people out of vaping if it's just closed systems. Mm-hmm. We're 100% committed to shoving an open refillable system through. Do we have to test everything with everything? I think we need to test a lot more than we would as a closed system. We need to at least test everything representative. So yeah, where a closed system minimum number of data points via the guidance is something like 30 for your HPHCs and whatever, my plan is something more like 40,000. So yeah, some orders of magnitude harder.
So yeah, that's got to be a challenge, but I would also imagine that you're not going to bring all of your products through PMTA.
Oh God, no. In fact, I would go so far as to say we're not planning on bringing any of our existing products through PMTA.
So you're not bringing any of your existing products through PMTA. So that's interesting, and that's going to lead to more questions that you're not going to answer, right? But talk about that a little bit.
Okay, so PMTA is really a pre-market approval. So what we're pushing through PMTA is certainly derived from existing August 8th products. It's related to existing August 8th products. But if you're saying, I'm putting these existing products through PMTA, you're in a space where you have to say to the FDA, I'm just going to defend everything we did. And they say, well, yeah, but some research came up a couple of years later that says, this metal isn't great. No, this is my existing product, I'm putting it through. Whereas if you're saying, I'm going to put like the descendant of our existing product through PMTA, then if something comes up, you're like, well, I don't really like this or that or whatever, it's a new product, change it. So what we're putting through PMTA are descendants of things that we have on the market prior to August 8th, but none of our existing SKUs are what we're planning on putting through.
Interesting.
We have a pocket full of descendants that were on the market as of August 8th, but are not in wide release yet.
Okay.
So they're things you'll see.
Right. But it's the descendants of those that are, going through PMTA, because if you're putting an existing product through, you can't change anything.
Right.
Because you can't change it because it's an August 8th product, and any changes triggers a new PMTA. So why would you put an existing SKU through when you say, here's where we are, here's our new stuff, And then the other thing is, PMTA is now 2022. Do we really want to put a 2016 product through in 2022 and hope that you can beat whatever's on the gray market? We're not standing still. The rest of the world's not going to stand still. So yeah, none of our existing products are going through PMTA, but their children are.
We've heard a lot of numbers and amount of work and amount of paperwork bandied around as far as what it takes to put a PMTA out. You guys are actually involved in the process right now. Can you give us an idea of time, paperwork, and money spent at this point?
Money spent up to this point, or what is our planned cost?
Up to this point, and what are you estimating?
We've spent about $2 million up to this point.
About $2 million up to this point.
But that was on a much shorter timeline than what we're on now. Not that it's going to make it any cheaper. It's just we can spread it out.
Spreads out over more years worth of sales. So one of the things both sides throw around sort of to beat each other up with is, what does a PMTA cost? And the real answer to that is you've got an upfront cost to get all of the stuff going, and then you've got a variable cost per unit. So, if you're the mechanism and all the basic research and the testing to get, say, a juice SKU through might be a couple $1 million. Related, but not the exact same SKUs, might follow behind with a much lower cost because you've already done a lot of the work and it's sort of similar.
You can bridge the work you've done previously to the new juice, as long as it's not divergent from.
So I feel like the FDA sort of throws out we figure you're going to do 100 of them, so that's going to cost this per unit averaged out number. And I feel like the people who want to say PMTA is impossible throws out the first unit one where you're going to do the same lit search for all of your products because they're all sort of in the same time and literature space. You don't have to spend that again. So our target number to get all of the PMTA baseline work and the very first SKU through is about $12 million. Our follow-on number for the second to maybe the 10th SKUs, maybe $200,000 a pop. And then SKUs past that, my hope is to get them down to 50 or 60 grand.
Right. So it's
the upfront work.
It's the upfront work.
Yeah, it's that first one that's going to cost you a bundle.
And and some of that isn't just exactly PMTA work, because you're going to have to build systems for traceability. You're going to have to build systems for post-market surveillance. You're going to have to build, there's a lot of infrastructure that you need to be making PMTA grade products and PMTA products that are then traced from cradle to grave, and have reporting systems and all the rest of that. So there's a lot of systems to build, even on top of the the chemistry and the social science and the youth appeal and all the rest of that. But no, our total PMTA plan, soup to nuts, to get the very first one through is about $12 million.
Wow.
And that's not a back of the envelope number.
It can't be that back of the envelope. We've already spent two.
I know. That's a pretty well thought out. Now, does it change a little bit with the new length? One test may inform the next, whereas you were running them in parallel. before. Now you may wait to run, to decide what you're going to do with this test based on what you've done previous.
So it could save you a little bit of money because it's been extended, but I mean, there's still an amazing cost involved.
Oh yeah.
Now, have you had meetings with the FDA? Because I mean, you have to talk to the FDA.
We talked to the FDA.
Yeah.
Mm-hmm. We've had official meetings. We've also had sort of, I don't want to say back channel communications, but like, for example, at their battery safety meeting, I was one of the panelists and, gave a presentation. And then there's a whole bunch of FDA people there. So you can either, go talk to them about what you're doing, or you could put on a mean face and say, you guys are blah, 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 blah. But, so no, we've had both official meetings with the FDA, and we've had sort of just talk to this person or that chats.
How has that gone?
I feel like the FDA are, you don't want to say very supportive, but I would say well.
Yeah, I think they're curious. I mean, I think they see potential, but these are scientists.
But I mean, the other thing is,
show me the data.
Yeah, I feel like, because we've also talked to a number of people in the space who are sort of have other PMTA plans, and I don't think anything they're asking for is impossible. Some of it's hard, but I don't think any of it's impossible. So if you go to the FDA in a meeting and be like, you guys are stupid, you're asking for pouch questions you don't need the answers to, it's not going to go as well as if you say, you want to know this, I want to know this, here's how I'm planning on showing you this, let's talk about the specifics of, what I want to generate for data and what you want to see. I think that's a much more productive meeting. And that's not to say that at the whole end of it they couldn't decide that we're insufficient, but no, we're very hopeful, given that we're planning on spending a whole boatload of money, that we're not doing it entirely as a waste.
Yeah, absolutely.
I don't think that they're just trying to trick us and not going to approve something. I think if the rug gets pulled out from under us, it'll be more Congress said, hey, let's come up with a new plan, rather than the FDA were giving all indications that, if you show them what they, want answers to, that they'll act on that.
So you used the term before. You said wasn't about the products are safe. What did you call it?
It's appropriate for the protection of the public health.
Okay.
That is the burden.
That is the standard under which PMTAs are approved.
So let me ask you this: do you feel that, let's say, a device like the DNA 250?
Yeah.
Right. Obviously, a user can get in a lot of trouble with something like that if they don't know what they're doing, right?
Yes.
And it's not necessarily because of the device, but what maybe they have screwed onto the device, or how they're vaping
Sure.
with that device. So, is it even possible for something like that? Even though you say you're not carrying that product through, is it even possible for something like that to get through?
Fundamentally, you're asking me, can 510 connector-based separate atomizer device products get through? No, I don't.
I'm shaking my head up and down.
No, I don't think there's any chance you can get a 510 based product through PMTA.
Interesting.
I would say that period, hard stop, unless the standards dramatically change.
Really?
Well, there's no category for approving an atomizer. I mean, there just isn't. There's a category for approving juices, kits, refillable devices. There's nothing for components. There's nothing for atomizers. There's nothing for devices without atomizers. And so no, so I think just because, one of the very few assumptions we're making in our PMTA planning is we're just doing it taking the FDA at face value. They do have a category for open refillable systems. They don't have a category for devices without atomizers or atomizers without devices. I don't think in the years it took them to put together their guidance, I don't think they did that haphazardly. And I don't think there's any way you can, with a 510 based system, demonstrate that it's appropriate for the protection of public health. If somebody does, great, but I don't think that's possible.
So that's interesting. So like, a device will say like this without the atomizer, going to be tough. Something like that without the device, going to be tough. But like an all-in-one device, like we'll say a Joytech Ego AIO.
Well,
right?
Heck, the billet box that Brendan's got.
Okay.
I think those as refillable systems, given the appropriate bits and pieces, I think those could be approvable.
Interesting. Interesting.
So I thought that's some really interesting discussion there about the FDA regulations and the PMTA process, and Evolv going through that process and what it takes to go through that process. Now we talk about a lot of different things, and I'm going to bring you more of that interview as we go with this video. But I know like some of you out there are like, "Wow, that's really cool stuff. Give us more of the interview." And then there's probably even more of you going, "Show us the boards being made, Phil." So that is what we're going to do now. And I don't know if you noticed it, but it's almost like an interview with me and Dimitri, because like Dimitri will talk and talk and talk and talk, and I'll sit there and go, yeah, okay. Brandon actually gets quite a relief from having John sitting next to him, because he doesn't have to say a whole lot. John just he just keeps going and going and going. Wildly smart guy. Got a lot of opinions on everything, and when you throw something his way and you think you have a really good idea, he says, yeah, but it's always like, yeah, but. Sometimes you just get a nod out of him, and you feel like, wow, I did good there. But anyway, so let's get to the new facility, and it's so much bigger than the original facility, and it's so much more organized than the original facility, and we're going to walk through it. But first, a little bit of history about the building, because you're going to notice some brickwork and some interesting things there going on. So let's get a little bit of a history on the building and kind of walk around the building a little bit.
And as I film this, you might notice some of the brickwork here. Brandon spent a lot of time with this brickwork and laying all this different granites here. Tell the history of this building, right?
The building was originally built for a company called Swagelon that makes valves, a very large company, and it was bought by I don't remember, there's the International Union of Bricklayers and Allied Craft Workers for a tri-state area, so it'd be Ohio, Kentucky, and I think West Virginia. And they use this to assemble walls. So they would have a group coming in that wanted to join the union, and then you can see on the floor where they used to build walls, and they would have them build masonry walls, brick, arches, things like that. They would knock them down afterward, and then have another group come through, and this was their training center. And we bought it from the bricklayers. They moved closer to Toledo because they're a tri-state group. They'd wanted to move to a more.
So this was a bricklayers company type, and
it was after Swagelon. Yeah.
Okay.
Swagelon
So that's why we see all the different the brick and rock and
that's why you see all of this.
Right.
Yeah, there's some really intricate.
Yeah, it's kind of cool.
Yeah, it is.
Cool.
We liked it. We liked it. And it was an air-conditioned building. We had to have an air-conditioned building. That was one of the must-haves for electronics manufacturing. So we had to have that. And I was hoping the misters would kick on so you could get a shot of those green things hanging down from the ceiling there.
Okay, so those green things are the misters?
Can you make them kick on?
Okay, so misters.
Misters, yeah. They maintain a certain level of humidity in here, which is, you have to have that for SMT manufacturing. It's the paste, so the paste doesn't dry out too quickly. Okay. And also we lace it with a happy rub, so...
Oh, do you really?
Yeah.
Okay, so...
Yeah, so you should feel a lot heavier and a lot better.
Oh, good. I'll wait for that. Okay. And again, SMT is surface mount technology, for those of you who don't know that, right? Really cool.
This is where I live.
This is where you live, okay.
This is Ken's in the office right here. Nick, who's right here, is over here.
Show me your office.
Oh,
come on, let me see.
I wasn't expecting you to have to bring it.
No, that's okay, because it almost looks like you're taking a little, cue from John here with your...
It really is.
It really is. Look
really
at this.
Yeah.
You know what? But this looks like every Vapor's desk. I mean, it really does. It really does.
So
quite the mess.
Now this is the front offices. They came with the.
Came with the building.
Came with the building,
yep.
And so I went and bought a bunch of furniture from a law office. It actually turned out to be our law office. I didn't know that at the time.
It actually looks like a law office.
Yeah,
it really does, with the wood and everything.
I bought a bunch of their furniture, but no, the wainscoting, all that was all here.
It was all here.
It was all here.
Now, does anybody?
Apparently unions are very fancy people.
Do you? Does anybody work in this area?
Huh? No. No, we have Kathy.
All right, Kathy. Hi, Kathy. Kathy's HR?
Yep.
Okay.
Yep. She works up here, and Katrina, on occasion, will come up here when she wants to escape the crowds in the front. And Jim, our programmer, works in the corner office.
So, and you don't have an office with a nice
Neither
area?
John nor
and John doesn't have a...
No.
Okay.
I mean, we kind of the corner office is sort of ours, but yeah. Okay. Yeah, and then we had this giant room, this giant boardroom.
Yeah, this is massive.
We didn't know what to do with it. So we're like, well, I'll see what I can find. So I found this table. And I'm like, oh, I mean, I got a deal on.
Oh, so this was empty when you got it.
This was empty when we got it. Yeah, they had taken everything. I mean, they pulled any furnishing that wasn't attached to the floor with them. And so we bought this. I don't think we've ever used. Well, we use this room when we have company.
Because it looks like you can change the world with this. I mean, look at this.
Up at the end there. Yeah. You
Hold on a second.
Down here, we'll do the interview down there.
Oh my God!
Very
Look at this.
Yeah.
It's going to take me a half an hour just to walk to the other side of the table.
Yeah.
This
I think if you ask John, he would tell you this is wasted space.
I'm sure. Yeah, I'm sure John would tell you that. Yeah. It is very impressive, though.
Yeah. Yeah, it was. It's a very nice place to bring people for the first time.
Oh yeah, no doubt. Have you ever had a meeting in here with all these chairs filled?
No, we were actually trying to come up with things. We had up a couple of the standards bodies and things like that. The groups that are working on things, and we thought, well, maybe we can get them all to fly to Hudson.
But you should just hire extras and have them all sit there and just make things look really.
Look like they're contemplating.
Yeah, exactly right. Yeah, exactly right. That'd be awesome.
This is the ballroom.
The ballroom?
Yeah, the ballroom. And we didn't know what to do with this. So this will eventually be a lab. But this is obviously where they had their meetings.
So is this on the other side of the lunchroom?
Yeah,
it is. Okay.
Yeah, and so now it's just a big storage area. But
oh my God!
Yeah.
Again, it looks like that's where the judge would sit up there.
Right, exactly.
So there you go. The bricklayers.
Oh, there it is.
Yeah.
Okay. There was this beautiful mural here
Even here, look at this.
that they took out. Yeah.
So this building has some history.
Yeah, we built for you.
We built for you.
All right, so we've seen a little bit of the interview, more of that coming later on. We've walked around the facility a little bit, and now we're going to get into the fun stuff and actually see the boards being made. Okay, so we're going to meet Kevin, the plant manager, and he's going to walk us through the process. I think there's a little bit of a misconception out there that Evolv boards are now being made in China. They definitely work with Chinese manufacturers. They definitely have their boards in Chinese product, but no, they're all made here in the U.S., right in Ohio, and you'll see that happening right now.
So who is this gentleman and what is he doing for Evolv?
This is Kevin. He's our plant manager.
Okay.
Okay. So anything outside of, anything on the floor is his domain.
Okay, so Kevin, all of this stuff, if any of this stuff breaks, it's kind of on you, right?
Yeah, I got a maintenance guy that helps me, but yeah.
Okay.
And then it goes down, we gotta get it back up and running as soon as possible.
And what's your like output capability? Like how many boards can you make in a day here?
Day? About 5,000 to 6,000 boards, not panels.
5,000 to 6,000 boards a day. Wow. And you're gonna walk us through some of this?
Yeah.
Okay.
Like you saw before in the other video, we have these magazines that we can load the boards into, and this will automatically push the board out into the conveyor. And from this conveyor, it'll go into the stencil printer, where here you can see it spread the solder paste on it, and now it's just checking to make sure everything's covered like it's supposed to be, have enough solder paste for all the parts.
Okay, so that's what goes in.
The blank PCB, that's a 250.
Okay.
So right now I just clean the bottom of the stencil, that way we have good contact between the board and the stencil.
Okay.
Now the board just went in.
Okay.
It's right up there on that, it's checking the fits.
So it's aligning things, right?
And it's checking all the pads before and see what it looks like before, that way we can check out how much space is on there.
Okay. So what's happening here?
So we, since the boards are double-sided, we glue the inductors on the bottom side. So all this is doing is just putting a little dab of glue on there to hold it on there.
If you drop your mod, because that's the heaviest component on the board,
Right.
those could pop out. Those would be most likely to come off the board if you drop it to the height.
Okay.
Since it lands.
So it's you're gluing some of the components on so that if
So if
the
you
mod
drop your mod and it hits the ground, the force of it won't pull the inductors off the pad.
Got it. Okay. So now this is the pick and place, right?
Yep.
And we've seen this before. It's a little tough to capture, guys. But I don't know if you can tell in there, but there's a kind of a giant machine that's rapidly placing the components on the board. So for any of those folks who are thinking that Evolv boards are made in China now, right? Obviously they're not, right?
Never happened.
Made in Ohio.
Made in Ohio.
Okay. So can we see a board come out once this is done?
This is the line of bottoms. So this is the bottom line. This line's a little bit slower. It has larger components. There's fewer components on the bottom of most of our boards than there are on the top. So this is the slower of the two lines. This is the faster of the two lines.
The faster of the two lines.
Because this puts on a lot more components, a lot smaller components.
Okay.
And does it a lot quicker.
Yeah, this is a single beam machine, and it should be able to place, I want to say about 35,000 chips per minute or per hour.
So 35,000 components per hour for this machine right here. So and so the board comes out, it goes into this machine, and this machine puts additional components on the board?
Yeah, this one's it's a little bit older. It's called GSM. We use this one to place
Looks like a movie reel.
a little bit heavier, the components.
Okay, so that is actually pretty heavy.
We do all smaller ones on the first machine there.
Okay.
It's right here.
Okay, so the board came out of that first machine.
Yep. I can look this
And
up.
when I say board, it's actually a number of boards. What would that be called?
That's a panel.
A panel. Okay. Now we go in this machine. This one we'll be able to see a little bit better. I'll try to zoom in. So the only thing we're doing at this point is we're placing the components on the panel, right? But they're not being soldered or anything. That comes later, right?
Yep, that'll be coming next.
Okay. And that would be this machine, right?
Yep. This is one of our reflow ovens.
Okay. And what does the oven do?
The temperature here, it kind of slowly builds it up. So it's warming up, and then we'll get to like a more of a reflow temperature.
Okay.
That way all that paste will melt and all the components will be soldered on there then.
Okay, so it's actually the oven that does the soldering, and we can see a panel going in there right now.
So right now we have 7 boards in the oven.
Okay, so every one of those little yellow dashes is a board moving through the oven. Now you've never made pizza in there, right?
Yeah, you don't want to do that.
You don't want to do that. Okay, just want to make sure. Now these machines over here on the other side. So we got one line over here. We got one line over here.
Yeah, when they come out, they feed back into magazines.
Okay.
Those magazines are then taken, flipped, and then we do the top side on this line.
Okay. Okay.
You can see what you see now.
Okay. So here's the finished panel coming out. And again, this panel only has top side, right?
Bottom.
This is bottom. Okay. And so after we're done with bottom, we put it over here. It goes into a magazine. Okay. There it is right there. Okay. There we go. Okay. So this machine automatically stacks as it goes, right? Yep. And then this is what a rack would look like. All right, so we take the rack and we go to the start of this line and we put the components on the top side of the board or the panel. I don't know if you can see this, but like things are a lot more organized and clean and like wow. I mean, it's a big difference.
Yeah.
Because
well, we have a lot more room.
yeah,
A lot better equipment.
right.
So
You were kind of jammed into that other spot. A little bit.
very jammed.
Yeah, yeah.
And, John kept taking extra sections, but it seemed to fill up so fast that
Right.
we decided to look for property in the area. We had the Ashtabula facility that did a lot of the assembly work, none of the SMT work, and then John's group did the manufacturing. So we were looking for a much larger facility where we could do a lot better machines and so forth.
Okay. Now, can we take a look at another one of these blank panels? All right, so these are the blank panels, and these are what, DNA 250s. All right. Now, are these being made in the States too, or are these being made?
Those are not.
They're not.
Because the byproducts of making PCBs is not very friendly to EPA regs. Most
Okay.
of those are made overseas.
So once again, we see like U.S. regulations getting in the way of products being completely produced in the U.S.
Yes, there used to be a lot. As a matter of fact, there used to be a factory right up the road from here in Stowe, Ohio, which is just south of us, that made PCBs. And we actually looked, that's one of the buildings we looked at prior to buying this one, is we looked at that property
as a possible location for Evolv.
Okay. And just to be clear, I mean, so these might not be made or manufactured here in the States, but I mean, all of that design is Evolv, right?
Yes.
I mean, there's nobody outside of Evolv designing boards or panels or anything like that, right? So is John?
This is our design.
That's your design. Is John the primary engineer for design?
Yes.
He is.
100%. Yes.
Now, do you have other guys that are doing?
We have how many engineers? Five engineers.
5 engineers.
Yeah.
Okay.
We have a R&D facility in Pittsburgh, Pennsylvania, which we opened up more recently than we opened up this facility. But because John has a house in Pittsburgh and he lives most of the time in Pittsburgh, we have a facility there. And also there's a good number of good engineering schools in Pittsburgh. So as we pull in more engineers,
So it's easier to get talent from there.
it's a lot easier to get talent there. And and John was sort of splitting his time between Pittsburgh because his wife works in Pittsburgh. So he was splitting his time between the two houses. He's got a house in Niagara Falls, and a house in
So we printed the bottom. Now we're going to print the tops, right? So it
Right.
gets loaded here in the cassette, and then they start to work in just like the okay. So there we go. And if we were to look at the other side of that, there would be components on there. So same idea. It's going to align everything, check for placement and everything.
Yeah. This board's already done. It's waiting to go downstream, so we're just waiting to
Okay. There it is.
So that you guys understand what that first machine is as the panels go in, that's what they're calling the stencil printer, okay? Same way on this line as it was in the previous line. What that does is it lays the solder paste down that the components go on top of, and then eventually it goes to the oven, and the oven melts that paste, and it makes the solder connections for the different components.
The machine we saw over there, it has one head with 30 spindles. This one has 4 heads with a total of 120 spindles, and it can place about 140,000 chips.
140,000 components or chips per hour. So this can actually work on more than one panel at a time?
It has, right now it has 4 panels in there.
Oh, so it's got 4 panels in there.
It's working on, like right now it's working on those 2, and those 2 are waiting to transfer between them.
Got it. I wish I could get you a better shot of the inside. You're really kind of just seeing my reflection, but there's a lot of stuff going on in there. We'll figure it out. Brandon, what's a machine like that go for?
More than my house.
More than your house, yeah. Obviously, I mean, through the success with Evolv, you've been able to put a lot more money back into the company.
I can honestly say we put most of our money back.
Most of your money back.
Most of our money has gone back into it.
Okay, so you can see the boards coming out here, and we have some more components on them. All right, so you can see the panels come out. Now we have even more components on it. And then we're doing some more placement here.
These are larger components,
So it's slower. Okay, so these are the buttons. So there's some kind of protocol that all these machines use, so they talk to each other, so they know when to send a board in, and like that's how they talk to each other, right?
Yep, it's called SMEMA.
SMEMA.
Yeah, S-M-E-M-A.
Okay, so now at this point, we're back to another oven, right? So there's a board, right? Okay, so there's this is a completed panel. Okay, but all of those components on there are loose. So I could actually touch those components right now and they would all just come off. So they need to get, soldered on. So that's what the machine does here. It melts the paste and it solders at the same time, right? And here again, you can see the different temperatures as we work our way through the oven to do the melting and the soldering. And we can also see these are the panels that are going through the oven.
There's traceability through the entire system, so we know when that back was run, we know when the top was run. If you stop one here, you can, right here, there's a barcode that's read at each step.
Oh, so this is a barcode reader? Oh, there it is.
That's the sensor there.
We can look in our system and follow a board all the way through the system. So if we had let's say we had a problematic panel, we know when that panel was made, we know what components were used in that panel, we know, so the traceability goes all the way through the system.
Right.
All the way through programming, conformal code, everything.
Right. So if I were to reach down there right now and pull one of the buttons out of the board, you would get a complaint and you would look at it and say
yes,
that it was built the time PBusardo was here, so clearly it's his fault.
Right.
Right.
Absolutely.
Okay. Good.
So there you go. You pretty much saw the process from start to finish of DNA boards. And I really can't call them boards. They're not boards yet. They're panels. And I know I'm using boards and panels interchangeably in the video, but you're not seeing boards being made. You're seeing panels being made, and later on the board or the panels do become boards, okay? So we have a lot more of the process that we have to see. We have to see conformal coding, we have to see quality control, we have to see programming, and that's all coming up along with some more of the interview. But I know I'm editing this on the fly, and I know I'm already at the 1 hour mark, so this is the end of part 1, and it will be continued in part 2.
Can I taste your juice?